Hi, I'm Thaddeus Wacknamara, and until recently, I was working with medical insurance companies in order to assure that payouts to epileptic people whom needed medication were legitimate. This experience has led me to glean and acquire significant amounts of information regarding lights. In particular, LED, light emitting diode, lights. In the courses of my duties, I was expected to test and confirm if those people who were making the claims were in fact bona fide epileptics. This has resulted in me becoming a fairly competent expert in lights. In particular, light-emitting diodes. And for my viewers who do suffer from a light-induced seizure disorder, I promise you I will not be flashing bright lights or high-intensity lights of any description through this whole video. Unless I change my mind. Probably not. Let's start with a quick overview of light-emitting electrical devices over the years. At some point in time, Thomas Edison claimed that he was rolling some tungsten something mixture, despite the fact that he was the guy at the patent office. Yeah, he just happened to accidentally come up with some form of mixture which allowed for the incandescent light bulb. Sure. Anyway, that particular idea of making light is that you take a huge amount of voltage and you run it across a wire that is basically a heater wire, and instead of creating huge amounts of heat, it creates small amounts of heat and instead creates a lot of photons as an output. Photons are light. So Thomas Edison probably stole, allegedly, someone else's mixture for a light-emitting electrical thing that used fire, I guess. So we all know that if you get something hot enough, it glows. That's because it's fucking hot. Manufacturers took this on board, and over the course of the next couple of 100 years, they made thinner and more photoreactive, i.e. they would emit more light than heat, wires to put into their light bulbs. And much like one of the problems with vacuum tubes is that ultimately you're boiling off the material and you're using that boiling off effect to create light, which results in them having a finite lifespan that is shorter and shorter and shorter depending on when you bought your light bulb. A great segue at this point is that there is one fire station that's had a very old school light bulb with a very thick filament running for over 100 years. Planned obsolescence is real. This incandescent light bulb, which used the hot wire, which wasn't quite a heater, but it was definitely a good emitter in order to create light, was a massive step forward, because prior to that you had to burn whale oil or kerosene in your house in order to illuminate it. This had smells associated with it. And although we know, it's just smells, it's never really just smells. So let me tell you about Henry Joseph Round, who was horribly indebted by the fact that he, every time went to a pub, was called out, "Joseph, you're round," and as such had to go into the field of science in order to pay off these debts. He was working on a detector for radio waves, and instead he came across the phenomenon of electroluminescence. Electroluminescence means that if you run enough voltage through rocks, sometimes those rocks glow, despite the fact that they're not hot. This discovery went mainly unnoticed until around about 1927, where a man from Russia named Oleg Lusev, and I can only imagine in Russian that means Oleg loser, discovered that if you run enough electricity across certain, probably didn't exactly help that he wrote all of his papers in Russian, and the vast majority of the industrial nations at that point in time didn't speak Russian. Kind of like the hackers of today. At any rate, after running 110 volts across these crystals and gaining the tiniest little bit of glowing from them, Oleg did realize that there was an opportunity here, which he wrote again in Russian in some papers, for telecommunications to use this particular phenomenon in order to transmit data, which is what we do today. Skipping forward to 1955, Ruben Braunstein, working for RCA, which was Radio Communications America or something similar to that, was able to recreate the effect, like 30 years later, using different materials, but he managed to finally get a red lead to glow in a manner which was actually useful for a scientific measurement apparatus. It was horrendously expensive and really not viable for commercial use. Unlike an incandescent light bulb or something similar, it was very, very consistent. This success ultimately resulted in them trying to electrify a whole bunch of other different types of rocks, where they realized that various types of rocks glowed different colors if you put enough voltage across them. Now, it is a little more complicated than this, and we will go into it, but ultimately it's the same technology that they use to make transistors. A diode really is just a transistor with one leg chopped off after all. So how can I explain how an LED works without using quantum physics? I can't. It actually has quantum tunneling. Not really. Hang on. Bear with me here. Let's say you've got two sacks and they both have different piggies in them. One sack is full of pink piggies who are lazy, very lazy, but very hungry. And in the other sack, you've got a whole bunch of black piggies that are very, very, very adventurous. They love just like snouting out things. They're the sorts of piggies that you want to have when you're going and getting yourself some truffles. Hungry pink piggies, lazy. Black piggies, spicy. So your black piggies, when offered a bit of food, will rush through because they're really interested in exploring that and experiencing the nom-noms. The pink piggies are hungry and will work their way through at a slower rate. As they meet each other in the tubes, the power of friendship meshes them together and light shines out. Another more accurate way of looking at this is that you've got holes and electrons, and as you apply voltage across the crystal, electrons meet holes, and the recombination of them produces photons, and that emits light. It does so without creating significant heat. In my prior example, the treats represent forward current, and the pigs, the NP or PN connections. Now, some breeds of piggies are a lot more robust, we'll say, and therefore, when they meet in the middle and the power of friendship glows, they'll create more energetic or faster moving wavelengths. That moves the light that they emit up the electromagnetic spectrum from at the bottom where infrared is all the way up to where ultraviolet is. It moves up the spectrum. So you go from infrared to red to ultimately gamma ray lead, but fuck knows what material we're going to make that out of. Bacon? Has anyone tried that? So now that we understand how piggies come together and fall in love... No, wait. Now that we understand how holes and electrons result in emitting photons, what we're going to have a quick chat about is some of the applications of LEDs over the years. And it's worth noting that the commercial LEDs didn't really come down in cost significantly and weren't really viable until about the 70s. You might notice that I've been a bit sparse on the later stages of commercial LED, red LED production, because Nick Holniak? Look, it's really difficult to say, so fuck him. Also, most of his colleagues were sus on him because of the fact that it really wasn't very bright. And it took him years to actually get something useful out of it. Which just goes to say, the next time that you're questioning whether or not a grad program at your local university is actually getting anywhere, the answer is probably fucking not. Maybe. Plus, who the fuck had the idea of plugging in rocks? Like tying them to a rope, like Mechanical Batteries video I did. Rock on rope makes sense. One particular old mate, whose name fails me right at this moment in time, was actually attempting to create a laser diode and instead accidentally created the infrared diode, which, depending on which way it was pointed, he probably had the better outcome than doing it the other way around. So moving towards where LEDs were actually useful, we could put them in every fucking thing. So we did so, and this basically kicked off in the 80s, mid-ish 80s, late 80s, where everything started replacing incandescent light bulbs and other solutions with LEDs. One of the applications that was kicked off relatively early in this space was the idea of using infrared LEDs, so invisible light, but at the bottom end of invisible light, in order to send commands to our TV and or VCRs, and yes, I'm old enough to remember wired remote controls, believe it or not. We would use infrared LEDs to send commands from these fucking things all the way across the room to our TV, so that we could flick through channels and rewind back through that great scene in Starship Troopers over and over and over and over and over again. Thad, you say, we invented remote controls that used infrared LEDs in the 80s. Why are you talking about the 1996 film Starship Troopers? Because I can. And I will, again, and again, and again. But if you truly recall the 80s and had a infrared remote control and a VCR, you probably in fact didn't wear out Starship Troopers at all, but Police Academy 2. Because CPR training is important. And yet again, we end up at a point in time in roughly the early 90s where instead of using incandescent light bulbs or other forms of illumination, pretty much every single one of our devices used light-emitting diodes as their favorite way to indicate something was on or off or processing. An interesting impact of having the number of LEDs that we do indicating all the things that we normally wouldn't have necessarily put an incandescent light bulb into is that light pollution absolutely floods our entire existence every day, all the time. There are studies out there that show that people sleep less well, and generally are much worse off simply due to the number of little fucking blinking lights or constant charging lights and similar that pervade our everyday constant existence. Now, I don't know, I can sleep upright in a chair with a bottle of wine against my hip and a glass in one hand, not spilling the wine, and generally don't have an issue with that concept of whether or not I left the lights on or the TV still on. But at the same time, most people are not quite like me. Thank fuck. However, it is something you should really consider if you are not sleeping well and you do have a lot of different lights, especially blue lights. One of those breathing masks, but you wear them on your eyes. So for years we were able to produce different coloured LEDs using different materials, but blue ones really challenged us. Blue as a wavelength being created by the piggies kissing was hard. Like, ridiculously, stupidly hard. That meant that we had a gap in the overall spectrum, but also blue light has a really good wavelength for doing a lot of stuff in terms of data transfers. And eventually, a guy named Nakamura was able to finally appropriately dope PN junctions. You don't care. You really don't care. He made blue LEDs. Now we have faster data. We have Blu-ray. The blue LED thing was so non-trivial that I'm going to put a link to someone else's. I can't remember whose it is, so fucking have a look below. It'll be right under Sexy Cyborg's Reddit post about her blue upskirt LEDs. One of the uses for LEDs that might not be immediately apparent is that it's for fiber optics. So we use very fast wavelength LEDs and we press them up against glass as closely as we can, and we flash light down that glass at high levels of intermittency to represent ons, off, bytes, bits, and whatever. We send these flashes down the wire of glass at a high rate of knots. It moves the speed of light through glass, speed of light. Flashing light. Beep, 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 beep. And that's how we get really quick networking. It gets even better if you've got multiple LEDs that are operating on different wavelengths, each one of them sending a part of the signal on theirs. So you've got different layers of colors that we can't see. All of them are sending their part of it down the same piece of glass, and at the other end, something is reading those signals as they hit the other piece of glass, going, okay, this not quite red is a 1, this other not quite red is a 3, this other not quite red is a 4, and all of this purple is just like, it gets us videos, okay? We send 15 different colors down a tube at the speed of light, and videos come out the other end. Optical media, such as CDs, Blu-ray discs, and similar, also heavily required good quality LEDs. Really high quality LEDs that switched really quickly and were very narrow in their band of light was absolutely necessary for us to get optical media. Optical media being laser discs, my second favorite way to watch the Terminator movies, all the way down to CDs, my favorite way to listen to Michael Jackson's Dangerous. So in the modern day, LEDs are used everywhere. They are one of the most ubiquitous devices that we put into every single thing, from the backlight of our phones and TVs, which we'll talk about in 1 second, right up to the upskirt lighting of Sexy Cyborg's very amazing LED skirt. Link below. And as much as I could go on about how LEDs are used in medical devices and further about their relationship with telecommunications, I think the fact that we've used them in order to make insect traps is probably the most out there example, well, other than the skirt thing that I mentioned before. The insect traps literally use a particular color of light emitted by LEDs to attract bugs in. I mean, I used to use cheese on my mouse traps, but nowadays I've been corrected. I just need exactly the right wavelength of light, a little bit of circuit board, a 9-volt battery, a resistor, and mice come a-running. In a screen, like your TV, your phone, or otherwise, LEDs can come in a couple of different fashions. One of them is edge lit. On the edges of it, because your liquid crystal display is dark. It's liquid crystal with it's more rocks without electricity. But you've got the edge lighting from LEDs to illuminate it. OLED, organic LEDs. That's a little more interesting because they're self-illuminating. So each one of those little liquid crystal pixels is self-LEDing. It brightens itself. It's pretty cool. Beyond that, we also have quantum dot QD LED. Quantum dot LEDs uses quantum dot technology to increase the phosphorousness power of your screen so that you get a good combination of true black and very bright liquid crystal colors. They cost a fucking fortune right now. But ultimately, they're different ways of using what is a semiconductor technology rather than a heat technology or some other form of producing photons in order to light up screens. Light is hard. It's pretty heavy to make light. Then you have LED backlighting, which just means that behind the screen there's LEDs that are attempting to shine through it, and mini LED technology means that you've got lots of LEDs, which gives a more uniform outcome. It's exactly the same as the idea that if you have 3 big lights shining, you'll get 3 hot spots, and if you have 1 million small lights shining, you'll get 1 million indiscernible hotspots. Does anyone else remember the watches that TV said that if you looked away from them, the LCD hands would disappear? A perfect world would mean that we actually came up with a different way of doing liquid crystal displays that were better self-luminescing. But the fact that we have liquid crystal displays that have pictures, like the pixels are immeasurably small. Okay, not immeasurably, but imperceptibly. We're making this out of liquid crystals. I'm gonna have a whole nother video on this. Wet rocks that glow and show us videos. Like, for fuck's sake, what do you want? I'd also be remiss at this point if I didn't mention that car headlights have moved from halogen globes and other incandescent approaches to high-intensity LEDs increasingly over the last few years. This means that it's very common for a driver who doesn't realize the little blue symbol on their fucking dashboard means I'm blinding that poor bastard in a fucking normal-sized car is absolutely ruining my day or my night every time they come up over the hill and make me nearly run off the fucking road. This is also true for cyclists who have a degree of oscillation for their high intensity headlight relative to their rotating wheels. In theory, they shouldn't have a significant amount of lumens that are right in my fucking eyes, but I call bullshit on that, and next time I accidentally fucking drive into one of them, I'm not apologizing. The advantages of LEDs over a fluorescent tube or a traditional incandescent or gas-powered light bulb is that they use much lower power and last much, much, much longer. An LED light bulb will draw almost nothing in terms of current compared to a traditional 100-watt light bulb, or a fluoro tube which needs its own high power capacitors to even kick itself up to going, plus they use mercury. LEDs just use, all of those other 3 and 4 column nasty chemicals. They do last a lot longer, and they are a lot cheaper to run. And anything which is reducing the amount of power being drawn by lighting, instead allowing all of that power to be routed to AIs for me to be able to chat with my virtual girlfriend, I think is good. Overall, I think the propensity for us to move to LED based lighting for as many things as possible is really quite sensible. It uses less electricity, it creates less heat, It lasts longer, it's more efficient, it's brilliant. I don't see any real downsides to this. Look, there might be some people who are out there being poisoned by the whole manufacturing process, but isn't that every manufacturing process these days? If you don't want your kids to be poisoned by a manufacturing process, maybe you should do it instead of them. In conclusion, I don't think we could ever go wrong with using less power and generating less heat when producing light. Also, the ability to be able to create light in really, 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 really short bursts and wavelengths that are so much more controllable than anything we could have done using heat, because heat has a lead in and a lead out effect, is absolutely the reason why we have fast telecommunications today. It's literally the cutting edge of being able to produce a particle on demand in as close to real time, like zero latency, or as close to it as you'll ever fucking get. It's so important. There is a period of time in the not too far future where we will use this sort of optical processing for computers instead of, well, we already do use quantum tunneling and transistors. Stuff's changing. And if the light bulb being replaced by an LED or an array of LEDs is the first indicator we have of a new generation ahead of us, of whatever that might be, I wouldn't be surprised. I'm Thaddeus Wacknamara, and I'm whacking odd.